I'm streaming, yes. But I'm here.
Can I sit here? It's yours. Thank you.
Sí, tú lo ves. I get boring.
Yeah, I guess we should start since everybody got quiet. Everybody be attentive. Can you hear me? On the microphone?
Nope, I'm close.
How about now?
Better.
Thank you for coming to the concert of Surfing Angelina and Eisen. We're going to do a few songs. I'm kidding. Please settle down. Don't be shy. Seat between people. We have plenty of chairs here. I know it's gotten a bit precarious as people sit.
There's on the front. Three.
There's chairs in front. Yeah, there's 3 chairs in front for whoever wants to be valiant and sit right in front of everyone. Thank you for coping with the parking. As you know, we're not allowed to park on the plot next door, so I hope you saw the sign that we worked on last night. Yeah. Okay. Welcome to Laser Houston. It's our first laser, and we are so pleased to bring this program to you. The laser stands for Low Art and Science Evening Rendezvous, and this series features a short lectures and presentations on art, science, and technology. Founded in 2008 by laser chair Piero Scarpulfi on behalf of the Leonardo IST. Lasers are now presented across the U.S. and internationally, and we are the Houston laser. Each evening includes presentations of art, science, projects, news from the audience, so you are welcome to participate and encouraged, and time for casual socializing and networking. Here's a map of all of the lasers around the globe, and they finally put us on the map since we just started lasers in Houston. And these are all the organizations that host lasers across the world. You can see University of Art London, Puget Sound, UCLA, Berkeley, and of course the TransArt Foundation as well. So technology. They have journal publications that are academic publications in art and science, as well as a music publication and books. And they're in collaboration with the MIT Press. Since 1968, Leonardo has been creating opportunities for the powerful exchange of ideas among art science practitioners through publications and collaboration with the MIT Press initiatives and events. Serving as the global network of distinguished artists, scientists, researchers, scholars, and thinkers, Leonardo's programs focus on interdisciplinary work, creative output, and innovation. And our sponsor today, and the sponsor of Laser Houston, is the TransArt Foundation, which is the place that we are sitting in right now. And beyond a place, it is a platform for artists and researchers to present their work. TransArt is a disciplinary space that supports experimental work at the intersection of art and anthropology. Zervik Angelini, who is sitting here next to me, is a Houston-based artist, independent curator, and writer. Her work is rooted in the overlapping disciplines of art, architecture, and cultural anthropology. And may I just say, look at this architectural marvel that we are sitting in right now. It has garnished a lot of awards in the past year and a half. She founded the TransArt Foundation, a workshop for art and anthropology based in Houston in conjunction with Abed Hernandez. And Zervik has been directing since 1996, pushing the foundation's mission to support artists and scholars involved in relevant social, anthropological, and interdisciplinary research. So, do you want to say anything?
No, I just want to thank you all for coming, and it's really a pleasure and an honor to be able to host these laser talks here, and they will be happening every 2 months. So I hope to see you again.
Yeah, we thought that bringing laser to Houston is very pertinent since our city is known independently for their arts and for their scientists, medicine is immense, aerospace engineering, and of course the oil industry, petrochemicals. So because of that prestige independently, we thought that this would be a great forum for people to start collaborations and start seeing connections between the works regardless of discipline. So I will now present speakers of this evening. We have Keer, speech pathologist by day, ghost hunter by night is the title of her talk. And she is a speech pathologist, an entrepreneur, and of course a ghost hunter. So I like to think of her as teaching people how to speak during the day and teaching ghosts how to speak during the night. It's very interesting subject. We have Professor and Dr. Christopher Zahner. He is the assistant professor of pathology at the University of Texas Medical Branch. He is a doctor of medicine and a mechanical engineer. And today he will talk to us about from space engineering to coagulation pathology. So he used to work at NASA, now he's a doctor, overachiever maybe. So we welcome him to tell us about how that went about. And of course we have Johannes Birringer, Dr. Johannes Birringer, who is a choreographer, media artist, and professor of performance technologies. And his talk today is Chemispheres Constructing Realities. So, without further ado, thank you again. I'd like to relay Zervik's thanks for you guys joining us tonight. And yes, we will be sending you emails, so I hope that you signed up about the next talk coming up in a couple of months. And of course, we have technical director, Carlos. It is such an amazing team that we have here, but it's really just three of us, and Pelayo is the bigger part of his team. He's been working relentlessly to make this YouTube stream, so we are currently live online, and of course it will be archived as well, so thank you, Pelayo.
Thank you. I'll get started. I'm very excited to be here. As my title suggests, I am a speech pathologist by day and a ghost hunter by night. And I'm going to talk about turning ideas into action. So, real briefly, some of you may not know what a speech pathologist is. I've been working in over 27 years in healthcare. Let the youth fool you, I'm beautiful, I know. But speech pathologists work generally from here up, from the thoracic cavity to the top of the head, eating, drinking, thinking, speaking, augmenting communication. I also work in the neonatal intensive care unit where I teach premature babies how to suck, swallow, breathe so that they can grow and go home. I have a great affinity for brain injury and stroke patients that I also work with. And I'm also part of our geriatric care team and work with end-of-life discussions. But not only as a speech pathologist, I consider myself both an artist and a scientist. In terms of my artist skills, in my youth years long past, I was a dancer. I did tap and ballet. I taught hundreds and hundreds of children over the years. I still love to dance in any and all forms. I was a theater performer. I did that for many years. And today I still like to work in many mediums, including clay, oil, watercolors, pastels, and certainly crafts, as I have two young children. And so our house is full of many, many things. My goal is to retire to an island where I can sit on the beach and paint all day long. As a scientist, I want to know how everything works. I love the human body. I love the brain. It's amazing what our brain can do, whether it's in growth and development or if it's after some type of traumatic injury. I am a tinkerer. You can show me, but I want to do it myself. I have to get my hands in it. I need to physically do things. And so I learn best by doing. I am intrigued by research. I am not a researcher by trade. I have delved into this newly in my career, but the science of it just baffles me. It's so interesting. I still love chemistry, and thanks to my 10-year-old daughter, I know every chemical compound of slime, and the things that go into slime to make it perfect. If you looked at Clifton Strengths Builder, I'm a futuristic person. I want to know what's down the road. I want to know what's next. And what can we do? So tonight I want to talk about ideas, our formulated thoughts, our opinions. Everybody has ideas, but what does it take to actually act on those ideas? I feel like often our ideas are close to our vest. We don't share them with people. I think sometimes we're scared because an idea creates work. It's going to create change. And some people can't put their ideas into words, but maybe they can put it into a design or a picture or something that you can hold in your hand. Well, my colleague and I had an idea. Lori entered my office one day and she said, I wish there was better tools to take care of our patients. And specifically a population I work with is our burn patients. So it turned into work. We took action. We started reading and researching, and we got creative. We actually started in April of 2017, and we found out that we had a lot of problems. Problems with tools. How do we care for these patients? What's something that we could do to treat an old problem? This problem hasn't been around. It's an age-old problem. But why hasn't somebody done something before? If we have the best scientists and the best researchers, why does this problem still exist? And how did two speech pathologists sit down and go, we think we can change this? We learned a lot. It took 6 months of reading books and articles and all sorts of research and technical things about how trauma can affect your face and your skin. As one idea turned to another, and made more actions. We wanted to figure out how we could help these people who had poor hygiene. They had trouble with feeding and swallowing. And my most significant is they can't make facial expressions. Imagine if you woke up one morning and your entire face not only was contorted, but unintentionally Botoxed. You couldn't look at your child and give them that evil eye and say that you're mad. You can't smile. You can't wink at somebody across the room. This to us was really important. And everything we found that we could use just was so limiting. And we knew we could do better, or we thought we could do better. So again, our ideas took more actions. And we tested our hypothesis and worked within our scope of practice. And in the hospital, we used things that we could find around in the med rooms and the different tools. And we trained one incredibly diligent mother. And she did this for 2 months with her son, and she tested some of the things that we thought could make a difference. And after 2 months, this young gentleman, he could pucker and kiss his mom, he could smile, and he said, "I'm handsome." That's when we knew that we had to really start moving forward on this tool. So ideas make work. This is a prototype number 2. I made this in my house, and this is where it started. I had a caulk of silicone that you use to caulk around your windows and baking soda. And I used that caulk in different mixtures until I got what I felt was just the right softness and just the right firmness. With this prototype, I took tongue depressors, and with the help of my husband, I shaved them down on the saw. And there was this prototype, number 2. And then went to prototype number 3. We changed size, we changed sticks. Everything we did, we logged in our prototype book. We have 3 books, about this big each. And every day we changed something, everything we did something, we wrote why we did it, what was the intent of it, and what did we want to get from it. And here was prototype 5. This prototype, again, made on my kitchen counter, had the same silicone caulk and the same baking soda. The handles were made out of floral wire, and they were covered with Instamorph. So I took that and I went into our health makerspace lab at the university. And again, my idea forced me to learn and grow. I didn't want someone to do this for me. I wanted to know how to do it. I wanted to tinker. And so they showed me how to do 3D CAD design drawings on the computer. Now, I have to feel and see things. It doesn't translate to me very well in programs. So I learned a whole lot. And I also learned how to make 3D printing. It was a full year it took us to get to where we are now. So this was my first makerspace prototype. It is not even close to what I kind of wanted, but I learned. And I saw what I did on the computer, what it came out to look like. I learned what the shapes were. I learned what a millimeter was. It's way smaller than I ever imagined. I learned how to measure. An old adage, measure twice, cut once. I learned that the hard way. It was over 80 plus hours to get to the next revision of prototype 8. And this isn't where we are today. I believe we are on 23. Because everything had to change for a reason. And documented. So now that we have our tool, and this on the left is an example of one tool, we said, okay, we got the tool, now what? We had to create a treatment plan. So our idea created more work. And with this treatment plan, we had to write an instruction manual, we had to write things, we had to have things translated into multiple languages so that it was as simple as humanly possible. And we were really excited. And from here we went, wait a minute, but how are we going to tell if it works? What do we do now? So I went science, because I needed to learn how every change in every expression could be measured. So in forensic science, if they have this crime scene or they have something to investigate and They can tell how tall this man is in the photo by taking the average height of a door, say 9 or 80 inches, and repixelate the picture to size and then create measurements. So I spent hours learning how to do this in Adobe Illustrator with my photos. And I figured it out. And I facial reanimation. And so from my facial reanimation, I went, wouldn't this be nice if somebody could make this a computer program? And someone did it for me. But if you look, and if I go back and forth, I can now look at the change. I can look at the degrees of the angles, I can look at the length of the facial musculature and how it changes. I clearly didn't do this on my own. I had help. And this is one thing that I think is incredibly important, and one of the reasons why we are here, to talk about interdisciplinary work together. As a university employee, any intellectual property has to be offered to them first. And we thought, never in a million years. They'll just brush us by and say, that's cute, keep going, girls. But they didn't. They thought it held value. And so they put in a provisional patent for us. They believed in us and they gave us grant money to help continue to work towards commercialization. And in that same office, Dr. Moen said, I can help you do your software coding for you. From there, we helped each other again, and somebody told me about another area, another avenue. Dr. Celia Chow, who runs the Institute of Translational Sciences, said, come on in, sit down, let's talk. You've never done research before. You're not a researcher. Let me show you what we need to do. From there, she set me up with the Office of Clinical Research. And they said, where are your grant writers? Where are your IRB writers? We said, there's none. It's just the two of us, but we can do it because we can follow directions. And we successfully wrote and had our own IRB accepted with minimal help from the outside.
What is IRB?
Institutional Review Board, who goes through, the question was, what's an IRB? The Institutional Review Board at the university takes all the protocols and all of the data and the research, and they approve whether or not you can conduct this research. And because ours was a human clinical trial, it goes through another level of safety, and you had to go in front of all the physicians and explain to them why this wasn't harmful or risky, and they did approve our protocol, so we're excited about that. We have people that are helping us with grants because we're going to need a lot more money and a lot more help. So also I have to say to my legal support, Mark Wisner, who is a colleague and friend, I wrote my own patent with the help of Lori and a few technical terms, and then it was submitted to the university, who their legalese fixed it a little bit. So, and then certainly to Ison, who has continued to help. And I love the fact that she knows I want to do it myself. She knows I want to get my hands in there. But just one little phrase can move me to the next level. Something as simple as, silicone likes to stick to silicone. And that launched me into my next. We are currently working with a phenomenal engineering company in Danville called Sparks Engineering, who for next to nothing, because they believe in this project, are doing professional prototyping for us. Today we have an approved IRB. We're enrolling patients with facial burns for an 8-week study. We have a patent pending at the U.S. office, and we're pursuing a grant. And we are working, special thanks to the one comment from Ison on a new version of inflatable tools. So that's what I do in the daytime. And this part's just a little bit fun. So like Ison said, I do talk to live humans during the day. And throughout my life, I have talked to people during the daytime, but specifically after hours, after work. And I am a ghost hunter. And so again, I had an idea. And my idea turned into actions. I apologize that this is an audio, and it won't be, I cannot play it, I'm sorry, but you can hear the entire thing on the Galveston Ghost podcast. It was just released, I believe, yesterday. But I gathered an enormous amount of experiences on the island. I stayed at the haunted 501 room in the Galvez, Hotel Galvez, and I had encounters, and I have photos I have a cemetery that I enjoy visiting, and I have regulars there. And this was one of my regulars. His name is Toby, and you can hear him very clearly. This is a device that is called a spirit box, and it basically creates white noise. And I did bring it with me tonight if later someone would like to see it. It creates white noise and electrical activity, and the spirits are able to then speak to you through it. I have a little girl that every time I turn it on, she says, "Mama, hey mama," and she talks to me, and I believe her name is Josephine. And then I have another gentleman, 4 consecutive visits to the same place. He says, "Can you see me?" And I'll tell him, "I can't see you," and he asks, "Can you see me?" So I wondered, am I the only person out there that talks to people? So I started going around the island of Galveston, because Galveston is one of the most haunted cities in the United States. And I started interviewing real people about their ghost stories. And I'm currently turning it into a book, but if you go, it's on all of the forums. I do have the Galveston Ghost podcast where you can hear interviews of other people, myself, and then also, I apologize, that last slide that didn't play. The whole, there's a 15-minute segment of one of my cemetery tours on there. And that made me have another great idea. And that idea is in action. Coming in the end of the spring into the summer, we will be doing Galveston Ghost Bus Tours off of the seawall. And of course, one day he gets another idea. And I have a new company on the island. This is my entrepreneurial ship. It's called the Galveston Experience Company. And we will be hosting tours and historical tours and many, many other things on the island. So ideas are fantastic, and they take work. But it really is a blending of art and of science in many ways. But I want people to help each other, to be the very best self that we can be, to create some incredible work. It's not because we're going to make money or because we're going to get our name in lights, but the feeling that you get when you've been able to help somebody and know that it's helping move them on to the next level is probably one of the best things that you can do. See the greater good in helping others. And remember that your ideas are fantastic. They are, and they beg for action. So in the words of Thomas Edison, the value of an idea lies in the using of it. Thank you.
Kind of crummy going after that. So anyway, my name is Chris Zahner. I am now a clinical pathologist at UTME. I was originally a mechanical engineer, and I worked at NASA for 6 years. And so I wanted to talk about my experience moving from aerospace engineering to clinical pathology. And I thought that it would be you people come from a slightly different background, generally art and interesting design. Mechanical engineering isn't quite like that. It's a lot more less form, a lot more function, usually ugly. But I thought that what we could do together would be talk about simplicity of design and how, with some of my experiences, simplicity has trumped complexity. I think all of you would probably appreciate that. Especially in medicine and in aerospace both, people seem to like complexity, almost for its sake. And I think that a lot can be gained by doing things as simply as possible. Generally, the more robust the system, and usually has more impact. So we'll go over a few examples, and I think you'll see what I mean. So just a little bit of background about me. I went to the University of Florida, met my wife there, and she dragged me here. She and I both worked at NASA. She had a better grades, so fortunately I was able to come also. I worked in mission control for the Operation Support Officer, OSO, the call sign. Basically, we fix stuff on board the ISS. And then after a while, I got a little bit, I wanted to go dive deeper. So generally speaking, that's a sort of high level knowledge about lots of things. So I wanted to dive deeper into a piece of hardware that I love. It's called the WHC. It's the toilet on board the space station. So I was lead OSO for the toilet for 2 years, and then I became the engineer lead for the toilet. That's me with WHC, and it was my baby for 5 years. Yeah, I don't know what else to say about that. It was fantastic. Anytime there was problems, they would call me, day or night. Until I went to medical school, West Texas in Lubbock, and then I was fortunate enough to come here to Galveston. So, aerospace. This is mission control, figure 1. It's extremely high intensity environment, and one day, we were going to reconfigure the ISS. The plan was to, in the short term, you can see in the bottom image, that's sort of the original configuration with 3 modules, 2 Russian and 1 US, and the solar array wings that are on the top, the big wings, those are going to be moved. Those are called T6. They were going to be retracted and then moved, and then expanded again. Unfortunately, as part of the P6 expansion, the solar array wings just started ripping apart. This was about 10 years ago. And as they ripped apart, no one knew really what to do. And so we got together and we made this sort of cufflink for the solar array wing. It was really just some bolts and copper wire. And we went ahead and put them into the little holes in the solar array wing in T6. And this is kind of what it looks like on orbit. It's pretty exciting as we're sort of waiting. He's out there really far, sitting out on the edge of an alarm. The SSRMS is, so that's Scott, Krasinski. And you see that stuff. And it was pretty amazing. So we did that in 2 days. And the ISS is not just a microgravity environment, it's constantly moving, avoiding space jump and changing its orientation. So it was getting, the hole was getting bigger all the time, so we had to fix this quickly. We did this in about 48 hours. The team was really hard to do, but a very simple approach, and we have yet to change that. So those cufflinks are still there. We built them on our crew members' wrenches. It was really exciting. Really fun. There you can see the way these was, and you can see in the bottom image the cufflinks are still in place in P6. So I went to medical school, left all of that. It was super fun, and I figured that medicine, with all its money and patient care, that simple solutions like that would probably not be applicable. But I was wrong, of course. What we have in the microbiology environment is really fast turnaround times matter a lot to patients. So this is a graph of how important or how likely you are to survive if you correctly diagnose sepsis. So how long it takes you to correctly diagnose sepsis to what's your survival rate. So if you wait 6 to 9 hours, it's 32%, but if you can do it in an hour, it's 82%. So the problem is that in a lot of microbiology or microbiology divisions inside departments, we don't isolate the sepsis very quickly. What we do is we grow it on a plate, and then we physically look at the plate after about a day, and then we do some chemical testing on that plate, and then we isolate whatever the bug is, and we decide, okay, well, we'll treat it with this antibiotic versus that. And the problem with that is, of course, like I said, the time frame is completely wrong, right? I mean, if I waited 24 hours, I would have 9% survival rate, versus if I could find in an hour, I would have 77% survival rate. So we got a problem. So we decided that this was Ison's predecessor, Andrew, and I worked on a project where we would isolate those bugs as quickly as possible. And we would do it using little Raspberry Pis and cameras. And so basically, what it is just a camera that takes an image every 10 minutes and looks for bacterial growth on those plates. And as soon as there's growth, it emails us. Really simple. That's not hard. That's not complicated at all. And what we found was we could isolate, we could improve time to detection by almost 12 hours on most bugs and 16 hours in others, fast growers. This is simple solutions. This is extremely expensive to do from a normal health operational perspective. What you have to do is increase your FTE, many more people. But instead what we did was we just build these things and they're like, I don't know, $40 or something. It makes a huge difference when it's your mom, or your kid who has sepsis. Right? And what's amazing about that at a place like UTMB is, and with the makerspace, is that we can do that. They're allowed to do things that maybe at larger institutions, more sort of monolithic institutions, you couldn't really do. We were sort of flexible. And so, like Ison and Andrew before her, make that possible. We just couldn't do that anywhere else. So, I'm going to give you guys one more story. It's a little bit more complex, but again, simple. So, NICU patients. What I mean by NICU is that, neonatal ICU. These are generally babies that have been born prematurely, 26, 28 weeks. You can see that that baby right there is attached to actually less than most. I use this image because that way you can see the baby. But oftentimes there are all kinds of stuff all over. You can see a pulse oximeter on the foot on the left side. Positive pressure for breathing. Generally speaking, their lungs are poorly developed. They don't have enough surfactant in their lungs, so the lung doesn't actually open. So you have to actually push air into the lungs so that it will open up. There's a problem with the processing of blood, hemoglobin. So what will happen with babies is they'll get jaundiced. And so you have to give them light. So that's why this baby's wearing those cool shades. Because the light is damaging to their eyes. And these babies also have so little blood that every drop is precious. And so about 2.5 ounces of blood for that baby right there. It's pretty amazing. And we, in the hospital, we operate on blood, and that's like what the hospital needs for everything that we do. And so we're constantly poking and prodding these babies to get more blood so we understand. So these babies have a number of problems just by being in the NICU. But this is not an exhaustive list, this is a bunch of things. The biggest problem that we saw was, you remember that every drop counts, the 2.5 ounces for that baby? Well, 30% of the time, when we get blood from those babies, it'll clot in the little tube, and we put it straight in the trash can. That sucks. So we thought, well, maybe we could do something better than put it in the trash can, right? These little babies are so precious and so small. So we started looking at what we do at UTMB. We do better than the national average. We're pretty good. Our NICU nurses are about 10%. We put it in the trash can. But it's still 10%. Straight in the trash can. Straight in the trash can. This is just some data that show you exactly what our rates are, but about 10%. So remember, from baby, what happens when we take that blood? Again, if it clots in the tube, lots of things get messed up, and we can't use it. And by the way, this is what I wanted to show you, that how do we get the baby? The vein in the baby is so, and if you poke it, you can collapse the vein, destroy that vein source, and then that's really bad because now blood won't return from wherever you got it. Right? So now the blood will pool in the arms and legs, and the baby won't do as well. So what we do instead is something much more humane. We stab them in the ankle, and then we get the drops one by one out of their blood, or out of their ankle. And that's why it clots so often, because we just stab them in the ankle and squeeze the heck out of their ankle. And so we get into a little bit easier. So you can imagine why there's lots of problems with that. One babies in the NICU don't like socks later on in life. Simple things like that, because they've been stabbed in the ankle all the time. It's not a big surprise. So, now, let's try to improve this. This is the problem. Drop by drop we're getting this blood. The rate is so slow. What do we do to improve it? Obviously, with repeated attempts, you've got volume loss that gets to the 2.5 ounces, infectious risk, stress, reducing access. Once you have hematomas in the ankle, you can't keep using that same location. You have to use a different part of the ankle. So these babies will have like a bruise and then a bruise and then a bruise again on that one side. So we have to switch sides and stab them on the other side, and hopefully that bruise goes away. And maybe we stab on the other side of that foot. It's pretty terrible, actually. It's pretty barbaric. So our goal is to do something really simple, and it would improve our clotting rate. This is just current status. This is stuff we've already talked about before. Obviously, several devices have been concocted in the past, and none of them actually work. So, right now, what we've done is we've designed our own, where we put it onto a little koozie. It's like a little microvortex. So all it does is it goes around the outside of the microtinger, and it has a little foam vibrator motor, and it just mixes the two while you're collecting. Super simple. So what that does is, inside the tube is an anticoagulant already. It's always been there. That's why it's only got a 10% clotting rate at TV. But the little micro motor mixes the anticoagulant in the tube in real time, so that it won't clot. And so we have that to get an IRB because NICU babies, they don't get IRB. So we had to prove, and we've done 4 studies now, that prove that this will basically take our clotting rate down to 0. So all I did was I took a 3D printer, made what amounts to a koozie that goes on the outside of the tube, and stick a motor inside, and voila, we're not going to have any more clotting. Right? Super simple. I'm rocket scientist to make that happen. It's just really easy. But yeah, I think you can appreciate it. Really, all the big companies, right? They're focused on making lots of money, right? So they invest their R&D budget is not focused on stuff like this. So there's lots of places where we in the hospital could get better. For example, we could get better nosocomial infection rate. Right? People, every single day that you spend in the hospital is worse for you, right? It's not a clean environment. There's bugs everywhere. People are super sick. We could improve just hand hygiene very simply. You can imagine there's really no incentive to modify hardware design because there's no return on investment. All that stuff can be done in a place like the Makerspace. We can redesign all of those things and get IRB as long as we can prove that there's non-inferiority. We can do lots of things. So right now we have in the works several patent ideas that are going to be coming to fruition hopefully in the next 6 months. And the last one, there was a shooting, as we all remember, not too long ago, Santa Fe, and the utilization of products and hardware at our hospital needed to come to bear, or we needed to focus on where everything was so that we could optimize our treatment of those patients in an emergency. And we did very well. We did exceedingly well. But you could imagine a scenario where any local hospital doesn't know where their blood is or where that ultrasound machine is or anything like that. And so the Internet of Things and some of these other technologies are going to make tracking hardware inside the facility so much better. So we have a plan to at least track our blood physically. Where is that in the hospital? But you could imagine all kinds of places where maybe they only have one ultrasound machine, or maybe the X-ray machine is mobile and they don't really know where that is at all times. And it's your son who was in a motor vehicle accident and was rushed to the hospital. Finding all that hardware can be done very easily if we utilize some of these technologies. So you can imagine that this is just future directions for us in our makerspace. But I mean, holy cow, the sky's the limit. In the hospital, there's so many opportunities, and they're all very simple solutions. So anyway, that's all I wanted to leave you with. Simple approaches, I think, will make a big difference in our hospital. Thank you.
So, thank you. And I'm very excited to be here, and thank you for the invitation. And I'm honored to also be in this particular building. So please, perhaps for a moment, draw your attention to the space. Are you warm enough? And can you see? I have a lot of visual material, so I'm trying to hopefully trying to combine the ideas with the visual materials. I have some films that I wanted to show you. And I see friends in the audience who perhaps remember my old work today. I speak about the detail of my new work to move away from the stage in theater to exploration of atmospheres. And I call them kinetic atmospheres because I come from a dance background, and I am hoping to learn more an engagement of my audience through sensorial challenges, allowing them to become more of a protagonist in the experience. And so my first area of investigation, I think, had to do with space. Perhaps my architects here, please do contest what I say, because I'm obviously trading on perhaps thin ice, but I want to look at ways to understand space from an embodied perspective. So in a way, listening is moving to the foreground. How do I listen to the space? And then, of course, how moving through spaces, which we do all the time, how do we inhabit particular environments? And then, in the sense of beholding, not the visual, primarily visual orientation, but also a sense of tactility and a sense of perhaps hearing and touching and sensing your position in space and how you move through it. And my first way to connect dance to music and architecture was to listen to composers, what they had to say, and I found Xenakis to be someone very interested in architecture. In fact, and I'm not sure that you may all agree with what he says here, that as composers, we tend to perhaps work on a small idea and build it up, whereas architects have to think of the whole. Yeah? I'm sure there are different ways to build, but what attracted me to Xenakis were his scores. To me, they look like drawings, and in a way, when I think about drawing out movement into space, and I'm thinking now also about, in a physical, musical sense, vibrations, frequencies, how do frequencies travel in space? So I was intrigued by Xenakis, very intrigued. This is called the spectrogram. So someone has tried to visualize the frequency levels of the composition. And of course, it fascinated me that I look at moving off of paintings. In a sense, I was trying to also imagine what this translation means, to visualize sound through frequencies and vibration levels. became interested in writing about this as a sense of understanding how space, the way I built it in the theater, could become audible in my little drawings. They were meant to help me to understand where things might happen over the course of the performance in space, and where things might be heard, which of course involves then the audio side of creating your kinetic atmosphere. And again, I found a book by an architect which fascinated me, because when I opened it, it was full of extraordinary photographs, many of them of Buto dancers. And I asked myself, what did this particular architect learn from Buto dance? And what my design does say is that atmospheres in the space as it's designed has an effect on us. It could be calming, it could be perhaps making you nervous, because let's imagine in the subway at rush hour you're in compressed space, or perhaps the space is overwhelming. And so these effects became to interest me, and another side investigation that I really focus on is the light. So when we work in spatial architectures and constructions, we obviously take the light into consideration in very important ways. So some spaces like this one in Austin may create meditative calms. Others, this is a point of the bird's eye zigzag building of Liebeskind's Jewish Museum in Berlin. Interestingly, before it opened to the public, he asked the choreographer from Berlin to actually explore the cavities of the museum, the dark recesses and the abysses. And this is a frightening building, and I find it extremely challenging also for the imagination of how you can embody memory or history in a building. Wonky weather is the Buto-inspired training technique where the performers are in the landscape. So I'm moving quickly now to the outside to remind you that, of course, as performance artists, we also perform outdoors and we learn from the outside environment. So I have started to hold workshops in the forest. This is in Germany last summer, and we worked as foragers, learning how to move in the thick of the forest and also looking for mushrooms. And this has already become part of a rehearsal that I'm doing with a Chinese dancer in London. I'm based in London, but I come back and forth between Texas and Europe. And my students tend to come from China, from Japan, from Singapore, from Korea. So I have a strong interest also from these other cultural exchanges. And these are my research topics. Once again, the notion of how we become immersed in an atmosphere, and how can, as a director or choreographer, how can I help to make this atmosphere very rich and sensorially stimulating. And in the last 2 or 3 years, my interface design collaborators have urged me to include VR technologies, virtual realities. I told them that's not going to work in the theater, but we are trying to see what happens if the audience comes in, and at certain points in the space I'll hand you the goggles. Yeah? But not just so that you go into a VR hermetically sealed environment, but we're trying to augment the virtuality by looking back at physical elements. So now, to get you a bit inspired, just a few examples from outside, how choreographers today are building installations that involves the audience. They seem all very happy. I had a lot of trouble getting from one end to the other, because you're supposed to climb through these rings from one end to the other. It's very, very, very complicated. This is William Forsyth's work. He's a US-American choreographer who was based in Frankfurt for a long time. I saw this piece in London and also in Brighton. I show it because of the construction. The mechanical engineering construction here is just super. And since I worked also in sites where we had to build things, like I worked for 10 years in an abandoned coal mine, and every summer I ran a laboratory. And since we didn't have any electricity and any tools, we had to bring everything and then construct a space in which we could invite audiences to come. So this is an example of a very difficult invitation. Yeah? That's with the pendulums. The smiling face of this audience member, and I thought, how can I make my audiences enjoy the work that I do more? Because a lot of times my work is too serious and it doesn't really have any humor and it's not very light. So I'm trying to lighten up with this Japanese plan to build hanamichi for my audiences so that they would have the dancers in their midst and they could move around them and observe them close up. And be very, very intimately sort of observing and listening and feeling them. And at this point I have been working continuously then for some years, and we have been partners in the DAP lab with a design collaborator who's a fashion designer. So she said, we must also think about the sound that the dancers can wear on their bodies or generate through the movement that we can do inside the audience. So we developed these oral characters, and I'll show you now a small excerpt of my work so that you finally get to see what my choreography is like. arts on these crisscrossing hanamichis, and they each have a particular sound or noise that they generate, and of course it's more on the noisy side than the musical side in the traditional sense. But these are languages that they were using to create a sort of sensory impact on the audience that's really standing surrounding, moving across with through the space. And the dancers in a sense are actually also the instruments that are in their costume or that are activated through the sensor. She has a small sensor on the leaf on her hand that controls the film projecting onto the sphere. And this kind of interaction is still done by the trained dancers, and I asked myself, well, we cannot really make this sensorial interface repertoire available to our audience, but how can we invite them to move through spaces that open out to these questions of interfaces? So one way of moving to installations is one final theatre piece dedicated to an homage to the Russian Revolution and a futurist opera that was produced in Moscow. And again, I was looking at how elements in the space could be moved through projection and through the dancers and their interaction with film and sound. And the costumes, as you can see, are all built by Michelle Donjou. She has a real fascination with, maybe this is another simplicity of the electronics that can come with a guitar. So this dancer is able to play the strings on her chest. And this dancer kills the sun by her hand gestures in front of the Kinect camera. And I ended on the edge of the last section of my talk with the Tatlin Tower. You will appreciate this because it's a reference to the Third Communist International, and Tatlin had a vision of building this radio tower. And Michelle thought, why not have it on the head of a performer and become a sort of an autonomous system? So when she bends the sensor, a tiny coil begins to flicker around in the top. It generates a tiny metallic sound, which is captured by a piezo mic and sent down to the performer and a loudspeaker on her chest. So a very good creation at the moment is this little spiral. So when I saw Michelle building this and our dancers testing it, I thought, what if we could actually develop an environment that could be worn or the audience could move through and have another film which we don't have time for that shows how we can begin to work with architects in collaboration and look at materials that could be used as our skins for building an environment that is not static but moves. So the architects built this really wall that is meant to actually move and react to the way the audience behaves. And today we're going to use Kinect camera sensors to see whether the audience is coming closer to the wall or further away, and then the wall would open up, or it would close a bit, it would also change color. And they then sent us the appropriate materials so that we could start thinking of what we would do choreographically. And we worked for several years on this, and the utopian idea was to build an entire pavilion made out of this origami-like structure. And we were hoping that then we could build also some costumes and some wearable objects for the audience to have on them as they move through this pavilion. This was for me the most fascinating learning curve because I realized when they are talking about part of a building, they're talking about motors. So we had to actually suspend the structure, and motors had to be built. Software had to be written, so that thing moves. And I'm sorry to say, after the first weekend of performances, it already broke because the motors overheated, small motors, and at the third or fourth day of performances, we had non-moving wall. So now I show you very quickly how we arrived with our team and built the objects that we needed to complement this. So we are thinking of conductive dresses, we're thinking of projections that percolate through the space and add texture to the people who walk through it. We're thinking of digital projections and light. And conductive materials that can actually generate sound. We then have a shape of the costume. And we also built small objects that we wanted to give to the audience so that they could carry it through the space. Again, this is like prototyping, like our first speaker was saying. We have to kind of build these things from scratch and see whether they work. And in that sense, we are engineering elements of the environment. We thought of some big canvas, we thought of the aquarium, we thought of the small spherical objects which we call tecular, because they have just covered the Kepler planet. And I need to stop here because time is running out. So I ended the last section of the last few installations. Where from this idea of costume dimension, I have also started to build environments with some elements that work and also ones that don't work. So the origami wall is not a sail, and later it becomes a coral reef on the floor. And then for audiences to perhaps lie down in. And our small hand-carried objects, we have a special audience here of visionary people who came one evening. And it was fascinating to see how the blind people touched the materials that we have in the space. And to conclude now, how do I add the VR? Well, at one end of the performance space, I have these mosquito nets that are disguising loudspeakers, and we have 8-channel sound installations, so wherever you walk, you hear something different. And the dancers are now home. I no longer have dancers. I ask them to be guides and help us. So this one young helper who helps to put goggles on the audience, and then we are observing how audience members actually enjoy the virtual. Here's an image of the virtual forest. And what we are trying to accomplish is an movement between the real and the virtual. The person who's wearing the goggles can still feel and touch things in the environment that goes beyond just the visual interface. So we hope that the somatic experience inside the virtual reality is similar to the one in the installation, and then we're looking at immersion as an interesting feedback loop perhaps between the physical and the virtual. So here we managed to see a few slides of my last workshop just a few months ago in Romania, where we worked with all kinds of people just finding out how they would move with goggles on. And what would happen if they felt they were touching the real forestry, or feel the wind on their cheeks, or feel the grass under their feet. So what you do is to augment virtuality, you begin to bring in some real objects. These are simple foils, we have fabrics, we have rocks, and we have tree branches. And so sometimes when the person inside the VR world thinks she is in an artificial world, actually she can feel a branch touching her hair. And it's wonderful because people really seem to enjoy this kind of sensory relationship. How I can develop this, I don't know, because so far we only have one set of goggles, so I might have to have more goggles. Or the audience will have to come at a certain point and use the opportunity to wear them. And since the installation is durational, it's very long, it can be up all evening, it doesn't really matter, there's no beginning and ending. So the audience can drift through, touch, listen, sit down, walk around. And what I find very interesting is that people with goggles do not mind lying down and actually feeling as if they're swimming, yeah? And this was an interesting experience for me to see. So this is the origami coral reef, that the audiences really like to go inside something like this and see it as an invitation. So thank you very much.
Now we'll have a Q&A session. Anybody has a question? Do you guys want to come to the front so we can help hold the Q&A? I also forgot to introduce myself. It kind of became evident when they were talking about me that my name is Keer, and I am a medical device prototyper and an artist, as I've always been. And so that's why they know me, because they work in my lab building some of the prototypes, so that's why they're like, and Eisenheld. Like, oh, right, I didn't say who I am. So, thank you. Any questions from the audience?
Yes, so what is
So the UTMB Maker Health Space is so the UTMB is the University of Texas Medical Branch, which is a hospital in Galveston, part of the UT system, and they have Maker Health Space, which is a space, it's a fabrication lab, and we have tools for prototyping, and so we can create the ideas that any of the medical practitioners across the hospital come up with, and sometimes I collaborate with them, sometimes I just facilitate the tools to them. So that's what it is. Does that answer your question?
And you facilitate
training,
right? So
yeah,
you teach people.
Right. Yeah. Sure. Yeah. Okay. Yeah.
That sort of brings up the copyright issue. Who owns those prototypes and rights?
So UTMB owns everything. So that should answer like the overarching. But of course, the inventor is then credited. So when it's a collaboration, I do get credits. But when it's kind of like a facilitation, like for example, teach me how to laser cut, or it's how could you create this idea, or what do you think about this problem, and I come up with a solution. Then it's obviously a collaboration. No, this is the first in the country, and Texas crowd, guys. It's the first in the country. It's spun from a company called Maker Health from MIT, and the Little Devices Lab at MIT, and then they kind of pitched this idea, but the UTMB were the only ones that decided to go for it, and yeah, they were right. It's created a lot of new IP, which means intellectual property, for the hospital, and it's also cut costs in some of the procedures, because we can make stuff in-house now. We don't have to order everything. Anyway, enough about that. Yeah. Yeah. Oh, right. Oh, right. We have to set it up. Chris, you have to sit. You have to stand there. Shall we turn up or
Right there.
Christopher, where don't you go? I'll stand here. I'll stand here, yeah?
Well, no, but
So I have a question. What kind of a device do you have to capture the ghost voices?
I actually have it with me. I can show it. I can show it. Yeah. Is if you want to grab that blue bag. It is a speaker.
Just a regular speaker?
So you attach a radio that goes through, it scans channels so that it creates in the white noise. And what it does then is there are no sounds other than it's scanning channels, and then it comes out through the speaker, and what it does then is allows an electrical source where the spirits are able to attach to that and to but this is the low-tech version. You can get some really high-end ones that are made from jacks and speakers for electric guitars. We also have in our paranormal field some very interesting new things that are being made with the sensors from the Wii or the 360 video games. Xbox 360 has a bar. When you play the video game, what it does is it senses your movement, and so we're able to connect those to computers, and as we record, you can see the outline and images of the people that are there with you, because it picks up the physical body.
Wow.
Galveston has so many ghosts. First off, it has a very long history. It was first inhabited by the Karankawan Indians. They had some very interesting ritualistic things that they did there. And Bernardo de Galvez, when he actually landed on the island in Cortez, there was some discussion about quite a bit of cannibalism that actually occurred, and that goes back into the 1600s. Of course, the storm of the 1900, it's very underestimated how many people died there. It's actually up to 10,000. And when the storm came in and it leveled a large portion of the island, these bodies were carried not just through the island, but across the Gulf and found all the way up towards Texas City. So there were a lot of deaths. And when there was that many deaths, they didn't know what to do with all of the bodies. They were stacked up in and amongst the rubble. So if they could not be identified, they were buried where they were found. And up until the storm happened in August, and in October they were still finding bodies on the island and decomposed. So there's a lot of souls that met a tragic end on the island. There was also a lot of epidemics there. They had a yellow fever epidemic. And a lot of children suffered. There were 3 orphanages on the island, and a lot of the children in those orphanages contracted it as well, so there's a lot of child spirits that are on the island as well. So unfortunately, there's been a lot of tragedy with the storms.
there is something in common with three, and it's the space. But the space, how do you approach the space? It's totally different. I would love to hear each of you the difference between what we see here. I don't know if you know what I mean. space outside, space in the space, and the space of the ghost.
Okay, so when we look at, for me, space, I approach everything a little bit differently in terms of what my intent is when I'm in that space. I think when you look at what your intent is when you move into a location, whether it's outside or inside, when I come into my location where I anticipate talking to someone, I obviously enter it with a different frame of mind, whether it's in the hospital, whether it's in the lab, or whether it's in the cemetery. And I believe that you have to respect space and the energies that are within those spaces, regardless of where they are. So I think being very mindful of that. And I have a ritual that I go through to explain, just like when I go see a patient in the hospital, I introduce myself and I tell them why I'm there to help them and care for them or their child. I do the same thing with my ghost experiences, or when I go to try and get recordings, I tell them who I am and why I'm there. And I'm not there, I'm there to respect their space and to listen to what they have to say to me.
Yeah, I don't know that I have as well-formed thoughts about space, maybe as he does, or some of you do. But I will say that for me, a space like this, in particular, is a facilitator of thought in a way that other spaces are not. So, for example, my home, the hospital, those places have a lot of edges, textures, things that do not allow you to sort of think about one thing. I have a hard time thinking about more than one thing at a time. And maybe all of you can multitask well, maybe your brain is capable of doing it. I'm not. And a place like this, with the walls the way they are, the shape of the room, these sorts of things help me to sort of think unilaterally, one way, on one subject, right? And so this is a focusing space for me. So I think that's what you're asking. You're asking about this physical space, and this is the kind of space that would be, I would love to sort of hang out here. So that, I think that's what you're asking about. Most of the places that I've got 3 young kids, so there's not a lot of spaces. So I really do appreciate it. So I really like it. I've never been here before, of course, but I really like it. So I think that's what you're asking.
Yes, if I may perhaps use 2 brief responses. And we work on the space station, and of course, being aware of space exploration, for us in the theater, this is mostly a metaphor. So if we think about outer space, we might do a story of a cosmonaut on the stage, but we have to use it metaphorically and build perhaps a mini spaceship or capsule or something. We can explore ideas through their imagination. And I think what now interests me is also the relation of the external space to the internal space. And I use the example, let's say, of sound. We begin to learn more about the inner ear and the way our bones conduct sound. Also the way perhaps you close your eyes and move, let's say, blindfold through space, how your attention to the acoustic experience is enhanced. And how, physically speaking, of course, sound is waves and it travels through space. And I'm very much now exploring what acoustic psychologists are saying, and what people are helping me to understand about how sound travels in space, through space. So for me, it's a very rich, very powerful environment. Especially when you think about the outdoors, where you hear so many things at the same time, and you are capable, the brain is capable of isolating particular sounds that you want to bring attention to. And there's a difference between hearing and existing with precise focus. But I think I like what you said about the nature of the space and how it invites thinking. Because when you go to the supermarket, you don't think. Sometimes buildings just pose questions to you.
Thank you.
A few years ago, I was hit by a car walking past my house and suffered symptoms of. But one of the things that I went to Keer, I really loved it. But going through all of the stuff, I just found myself fed up and figured out. One thing that really helped was when a friend who was a sociologist reached out to me and asked me to come to the office and be in front of me to do neural feedback. And a few times I videotaped the whole session. But I was trying to explain it to my clients, and I showed them, and he showed them. It's really interesting. Do you work with that at all? Because I'm really a big believer in it. Hit some roadblocks with older, established people who aren't willing to take that into their practice, which is really unfortunate.
I think traditional medicine very often hinders us in terms of looking at new and different. I myself do, just because of what I'm doing right now in terms of my practice, I don't, but we have an incredible amount of mind and body that we need to continue to look at and see, because nothing happens in isolation, and we need to draw on all of the senses and all of the visualization and sound and even the left and right dominant hemispheres, and looking at having your body mapped equally left to right gives you the opportunity to work one side while fixing the other. And I think it's just another example of how we can continue to explore there. And I think everything should be given the opportunity to be looked at and to try.
So eventually, the evidence was there. The evidence was there on the ground. It's right in there. Learning about the brain and how cognitive stuff, anxiety levels, and also with space. Sitting in the chair, with the visual part, and the movement of the brain is actually the colors and the sound.
If I may, just a brief comment. This happens in events like this, and you hear someone speaking about their research. The neuroscientist I heard the other day from your age says it is no more left or right, that's old-fashioned. When they're doing the new studies now with EEG and also with fMRI, they think that the brain has so many activities, the neural systems are working everywhere. So that there's a very complex sort of relay system happening in the brain. But of course, I think they still can identify certain areas where there's more electrical activity, and whether that can then be stimulated to help in therapy.
Sorry, like I said, one of the problems with medicine is that we have abandoned empiric data for scientific pathophysiology, and that's sort of a pendulum swing. It used to be that we focused almost exclusively on empiricism, and we were getting data that seemed to work. This herb, this sort of thing happened, rub this here, do something like that. Now we've moved to almost exclusively a scientific engineering-based approach. And as a result, the things that you're describing have been discounted, even though there's empiric data. And the problem is that no one understands the pathophysiology because it's so complicated. And so as a result, when we don't understand it, we discount it almost immediately. And that's not fair, that's not good, but I think that empiricism would be a smart thing for us to go back to. Maybe the pendulum will swing. I think that there is evidence that it's swinging in that direction where data has value in and of itself if you understand the pathophysiology or not. I think, are weak in that area in medicine. And so we'll hopefully move away a little bit from the deductive engineering-based evidence, and we'll move a little bit closer to that. I think that would be wise.
Does not the constant processing of data, visualization software, prevent, as we call them, more semantic and experiential approach, where, for example, in mind-body centric or experiential anatomy, you learn about internal organs and your joints and your limbs through touching. And that maybe has to do also with healing mental stress, because it could be caused through physical stress. And so I think it's a wide acknowledgement now of the body arts. They make a big contribution to medicine.
So you have a question?
Oh, yes. When your dancers in the picture were wired up, were you gathering information, or were they making the music, or so their stomach rumbles and you
Some of the wearables are analog, so there are tiny speakers, there are tiny microphones, tiny sensors. The sensors send data to the computer, but very often we would like the sound to be generated on the body. So the worker woman had actually a small microphone that she was rubbing across the vinyl, and that was creating some of the noise. And the woman with the Aldonium had later on in the second act a costume with speakers on her spine. So the music was coming out of the spine that she was generating as a contact mic. So I like the fact that the body is an instrument body, so to speak. And you could, of course, have microphones, picking up your bloodstream and stopping noises.
Can I add a little comment? I love the idea of interdisciplinary activity, and I wonder if you were aware of these pictures from the World Wall, because I think the three of you could have very relevant comments on this representation of cosmic activity.
Of course they are. Ghostly rays. That she thinks also inspired early Kandinsky abstraction. And I'm fascinated with work by Moreno. And I think there is also a subculture of radio sound artists who listen to sound signals and voices. And it's so interesting to me that now the latest also sonic experimentation is called ASMR. Have you heard about that? Yeah. Where the artists are whispering.
I agree.
Shivers down your spine when they whispering.
I'm sure this rays can be transformed into sound.
You will have opportunity later on to go also to the other side, because her books and the works on display are really, really, really beautiful. And I'm not sure now what the role of photography is in her work, because these are photographs, right?
There's also one or two that she learned how to make the color changes, and she recorded an image that she got. And I think I'm not sure if this is.
This is the visual representation of the bouncing of the rays over the liquid surface.
And there used to be, in the science of air, I think at some point there was a belief in ether. And in the late 19th century, in some of the seances, they were trying to capture the ghost image of a ghost. And I think there are some very stunning images, and you had one too, a blurred image of a ghostly spectre. And the interest in spectres was, I think, prevalent in the 19th century. Today, I was surprised that you pursue this. I don't believe in ghosts, but I think I acknowledge the research.
But it's interesting how vibrations and sound is in all of your work, right? It was a solution for you, And yet this was an intuition or knowledge that came out of the futurist experiments from Malavich and so on. And so he was the first one who said that, you know, you had to listen to a painting. And he took the conclusion that, you know, that there was such it was an invisible part of reality that belongs to other vibrations that we cannot see. And sound is only one of those. So we realized that, you know, in this range of vibrations, you know, you would find the visible and you would go into sound and the invisible. And it's fascinating that all of you have been touching on, you know, on this range of going from the visible to the in order to reach your solutions and your creative work. Particularly Johannes. I mean, you're working basically with that flexible, you know, passing from sound to the visible, back and forth. It's very fluid.
And it was a shock to realize, as someone who had not really previously worked with communities of different abilities, so when we had an audience of blind people come, what they were hearing and seeing, yeah? When they touched the costumes or the fabrics and they moved around, they stayed for almost 2 hours, and then they told us stories on what they had experienced. It was very powerful.
I'm curious about how the tool that you developed helps to bring
The question was, how is the tool that we developed helping burn patients with facial trauma? We went back again to science and to the science of stretching. And what we're finding is, despite many of the same techniques being used year after year, we are not we're not expanding the skin or expanding the musculature of the face when we're doing our treatment. We're actually causing it to contract. We may be causing it to contract in a smooth fashion so we don't have hypertrophic and really keloid scarring. But what we found is that within a week, if you have a facial burn, in that 1 week you can have an extremely masked face. So we did the opposite. Instead of working on the outside, we're working on the inside. And so we're placing these tools inside the mouth because oftentimes the mucosa in the mouth is not as burnt. People eat, they can tolerate things much better. And so we're targeting at the basics of the Golgi tendon organs and the sarcomeres within the face to do a slow, low load, prolonged stretch. And what happens is, as the musculature slowly stretches, because it's contracted, it builds sarcomeres back up onto the end. It's the same concept in any stretching, that any one of us, if we decided we wanted to do the splits minus the joint round, if you stretch day after day and you hold into low load prolonged stretch, you will lengthen your musculature. So that was our premise.
So yeah, so you never really explain how they work. It's like a lollipop, right? So that she puts in the mouth and stretches the muscles.
It's actually, they refer to it as the lollipop study at the university.
It helps to understand the scale, because I thought there was kitchen spoons.
And so what we're looking right now in terms of feasibility is how big is big enough, how long is long enough. We have our anecdotal evidence from our first patient that we did it with, but now to prove and to be able to test on humans, you have to go through human clinical trials research. So that's where we're at.
Chris, you brought up the topic of simplicity, and if y'all could comment, I think each of you deal with simplicity versus complexity. What's the right approach in design when it comes to that? Sometimes I think complexity is necessary in order to stimulate creativity to overcome
Very sure. Yeah, so to answer that specifically, yes, right. There was a number of ideas. Not so much for the plate reader, the microbiology plate reader, but for the mixing device for the microsaners. Yeah, there were. So there's a whole way of solving problems, from very complicated to very simple. I'm attracted to simplicity because I like mechanics, I like physical things as opposed to electronic things. Sort of tend to be sort of that way. Maybe that's considered old school now in this Facebook and Twitter era. But the reason I focused on that is because most of what we do in medicine is to make money. Really, right? These companies are focused on money-making propositions, and they're right, and minimization of litigation. And so what they do is they only go after extremely valuable things, solving problems that have value to their customers, CMS and insurance companies and whatever. They don't consider babies in the middle of the night. So let me illustrate why they would not care about this. So what we do when we stab those babies' ankles is we do it in the middle of the night at 2 a.m. about. And there's no parents there. As far as I know, those babies don't submit any sort of like rating system for the hospital. There's no 5 stars from a 26-week baby. They just cry in the middle of the night, and then that's it. And so we don't know when we don't do well that they cared. So there's no one who's incentivized to solve that problem. So that's what I meant mostly by talking about simplicity. There are lots of things like that in the hospital where thinking a little bit harder can go a long way to solving problems. In the emergent environment, there are a number of things that we do that, so for example, intubation. About 1% of the time we destroy someone's face when we intubate, just completely destroy it. That seems odd that you would do that. If they can't breathe, why would we be ripping apart their teeth? We could probably solve that better. And so that's what I mean by simplicity. I mean going after very simple problems and saying, I don't really care so much about the profitability of this. I'm going to come up with something that we can implement soon that is unlikely to get me sued. That's not going to get me sued. And try to get something that's robust as a solution. That's what I mean.
Yeah, robust is a good word. And you had to iterate through many different tools, and I'm not familiar with how you do your stuff, but I don't understand how you use those tools. Do they work?
So the tools themselves, through our process that are having them placed, I actually had a slide, but I did take it out, where it showed me holding one up underneath. Each tool specifically targets a muscle group. So whether it's placed under the top lip or the bottom lip, we have large deep pockets into the buccal cavities. So they're put in there and they're held for a period of time. So it took quite a bit of resizing and remolding and refashioning and looking at angles of the face and the jaw to be able to get just the right size that we think, and this is why we need to look at it in terms of the research to see, is this good enough? But for us, it was very simple. We didn't go into big mechanical, elaborate types of devices or machines. It was something for us, a large population that we have are third world countries, patients that come to see us, and in these countries they still live where they cook on open fires, and they have pots, and there are a lot of children that are burned in those situations. And so we wanted something very inexpensive that it's disposable, you can give it away practically. That's going to make a huge difference. So we wanted to keep it as absolutely simple as we possibly could. And so that's why we chose all of the legwork ahead of time to try and get it very simple, because for us, hundreds of thousands of lives can be impacted by one simple little piece of plastic and silicone. So that's kind of our goal.
Any more questions from the audience? No? I think everybody's getting kind of tired by now. I've seen a few people get up, so yeah.